Hey guys, welcome back to some more polynomial review and kind of prepping what you would need to know for calculus. So let's take a look at some end behavior and kind of look a little bit more about the types of zeros that you see on polynomials. And we're going to kind of preview a very special theorem, which is called the intermediate value theorem. All right, so let's take a look at these three graphs of f, G, and H. And so what I would like you to do for those, notice the first one, it says, describe the left end behavior and the right end behavior of each of those. So pause the video and wait a few, I'm going to pause here for you as well. And then will you come back and then we'll talk about describing the end behavior. I'm also going to introduce a little bit of calculus and then I'm going to introduce some notation that's going to be used next year for you guys kind of as a little bonus to kind of get you used to seeing a new notation. All right, so pause the video, use what we learned at the beginning of the year, and write your end behaviors for the videos. I'm sorry, for the videos. Your end behavior for the functions. All right, so coming back in, what we're looking at here in terms of our end behavior is to remember when we do the left end behavior, obviously when we look at the graphs, the left side is going to be, of course, on the left, and then the right side is going to be over here on the right side. My internet's a little slow, so hopefully this will catch up as we are doing this. Let that sink for a second. All right, hopefully we won't have some syncing issues here. All right, so we have the left and we have the right. Now, when we talk about behavior, it's this idea of where is the graph going. Remember, your left behavior is going to be as x goes to negative infinity, and your right behavior is going to be as x goes to infinity. All right, so when you do your describing your behavior, I'm just going to scroll down now that we've kind of talked about that so that you can check your answers. That what you're doing is you're looking at it in terms of telling me what the y values are doing or what the function is doing as x heads in those directions. So when we did this before at the beginning of the year, we did this idea where we started with the tell me what the x is doing. And then what you were supposed to do is to tell me what the y was doing. So that comes second when you do it. So as x goes to negative infinity, the left side, the y values named f of x are going to be going to negative infinity. They were heading down on the graph. And if you ask where those y values are going, then what you're going to see is that those y values are going to be going down to negative infinity. So what I want to do is I want to give you kind of what the notation is going to be for this. And what we're going to do, these are what are called limits. A limit is where the y values are heading. That's kind of a loose general sense. We're in pre-calc, so we're not going to worry about a formal definition of a limit. But a limit is kind of a function that describes where the graph is going. It's just a notation that we're going to use. So I'm going to do it for the first one down here for this cubic function. So we always start by kind of putting a limit notation in. And so we use this lim notation. Sorry, I'm talking and pausing because for some reason I'm having technical difficulties this morning with this updating. There we go. So you write LIM, and that's the quote unquote limit function when we look at it. Underneath of your limit, you're going to tell me where x is going. So as x goes to negative infinity, so we want to go ahead and write that below, and hopefully it'll come up. I may have to restart my computer here today, taking a look at it. So there we go. So we take it, and so you write LIM, which says we're going to do a limit. Then you put the x goes to negative infinity right below that. And then what goes in is kind of like function notation. So you have to tell them what you're taking the limit of. So I like to put in parentheses, and you have to put your function name in there so you know what you are doing the limit of. Right? So it's kind of like a function. And then we go equals, and that's when we add in the where the value was going. And what this is it says exactly the same thing that we were looking at before, in that it was describing where the function is going. And again, my computer is really lagging this morning. All right, there we go. So if you take a look at this right here, so you have the limit. This says, hey, I'm doing a limit. I'm telling you where the function is going. That's what that tells us. The bottom right underneath of that, these two things kind of go together. And you want to say the limit as x goes to negative infinity. That's where you're headed. What goes in here would be the name of the function or the expression for the function. We don't really have an expression right now or an equation. So we're just going to put the name in so we know which function we're looking at. And then we say equals, because the limit, even though I know that up here we have f of x approaches with the arrow of negative infinity, we're going to say equals because this is a quote unquote function that tells you what the function, it's kind of a bad way to say that. The limit tells you where the function is approaching. So in the limit notation, we do put an equals there, not an arrows, like we would in the notation we used in pre-calc. All right, I'm going to pause here. I'm going to restart my computer, see if I can fix this. And you guys go ahead and fill in the limit notations for each of the items that are there. All right, coming back in, go ahead and check your answers to that. And again, the idea was you always indicate you're doing a limit here with a limit as x goes to negative infinity. That's kind of the verbiage of the English that goes with that. The function that you are applying the limit to, or that you are looking at the behavior of the function, goes on the inside as the input to this limit, and then equals, and then the answer is going to be where the y values are approaching. So check each of these, and you notice all of the first three each say the limit as x goes to negative infinity, and each of the final three for the right-hand behavior is the limit as x goes to infinity. Put the name of the function in each one and then tell me where they're going. And you'll notice that the right-hand behavior of all three of these was exactly the same. They were all going to infinity. All right, go ahead. I'm going to stop this video here. I know that's a really short video, but I need to work on my technical difficulties, and I'm not going to redo this portion of the video. Go ahead and write down your zeros for each of these functions. So give me the x value of each of the zeros, and we'll start the next video. I'm going to restart both of my computers and see if I can fix my technical difficulties.